Hello then welcome to a brand new video. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at prime factorization, okay? And we want to use the factor tree method. So without much ado, let's quickly look into it. When we talk of prime factorization, it is as simple and literal as it means. So it is writing a number as a product of its prime numbers or prime factors. There are a number of ways we can do this, but one of the easiest one is using the factor tree method. Okay, so what then is the factor tree? So the factor tree is just a diagram that breaks down numbers into what factors until all the branches, we know trees have branches, right? So until all the branches end in what? Prime numbers. So I would want us to quickly write out some examples so we understand, we have a feel of this method we are talking about. So starting with this example here, which is going to be our first question, it says you have to find the prime factors of 60 using the factor tree. Find the prime factors of 60 using the factor tree. So how do we go about it? We start with what? 60, and we write our 60 over here just like this. You see, now for every number, if so far as this is not a prime number, we want two branches attached to that number. You get it? So for 60, I'm going to get what? Two branches. Now with these two branches, all we want to do is any factor of 60 that comes to mind, you write it down. So in this case, I can easily say 6 times 10 gives me 60. So I'm going to write my 6 over here, then I'll write my 10 over here. Now, so far as the number is not a prime number, then you can still form a branch out of the number. But if the number is a prime number, that's fine. You end over there. It cannot form any other branch. Let's go for 6. Does 6 or is 6 a prime number? No, it's not. So it means we are going to form another two branch on 6. You see, and these branches should give us what? Other factors of 6. So in your mind, you can start saying numbers times each other that give you 6. We know 2 times 3 give us a 6. So I write my 2 here and I write my 3 here, because 2 times 3 gives me a 6. You get it? Then I'll come to my 10. So over here, is 10 a prime number? No, 10 is not a prime number. So I come and say, I know a 2 times a 5 gives me what? A 10. You see, now these are the numbers we have gotten. You ask yourself, is 2 a prime number? 2 is a prime number, so it is definitely not going to have any other branch. Is 3 a prime number? Yes, it is. So it is also not going to have a branch. Is this 2 also a prime number? Yes, it is. 5 is also a prime number. Hence, all these numbers are not going to give us any branch. That ends our tree. So to write our answer, we are going to say the 60 we have is equal to, it is good you write them in, let me say, ascending order. So we have 2 times 2, then times this 3 over here, and then times our 5 over here. You see, and if you want to write it as index notation, you have 2. How many times is 2 multiplying itself? Raised to the power 2 times 3. There's just 1 3 here, and then times 5. So 60 as product of prime factors is what? 2 raised to the power 2 times 3 times 5. You see, this is one method of using what? The factor tree. You see, where you can use any factor at all. Now, there's another one that if you write your 60 down, you want to limit yourself. You see, so what do I mean by you want to limit yourself? You want to limit yourself strictly to the prime numbers. So we know our prime numbers. I'm writing them down here. We have 2, then 3, then our 5, 7, and it goes on and on and on. So this other method, which is also the factor tree method, you want to start with the smallest prime number. So with the smallest prime number, you ask yourself, can this smallest prime number divide 60? If it can divide 60, then you come here and then form a branch. So our smallest prime number we want to use here is what? 2. So I'll write my 2 over here. And then 2 times what gives me the 60. So I know 2 times a 30. You get it? So in this case here, you would realize that this 2 is a prime number and it's not going to form any branch again. Now we are going to depend on the 30. So we start from the 30 again and ask ourselves, the smallest prime number over here, can it divide 30? Yes, we know the divisibility rules. Any number that ends in even is divisible by what? 2. So we can say that what? 30 has got 2 times what? 15. Once again, we can tell that this 2 over here is a prime number. You get it? Then we come to the 15. Is 15 a prime number? No. So if 15 is not a prime number, then we are going to continue our branch from there. You get it? So going straight to 15, we ask ourselves, which of these prime numbers can then divide 15? 2 can definitely not. Then we go to 3. Can 3 divide 15? Yes. So 3 times what? 5. You see, with what we are doing now, our branches are only continuing from the composite numbers. That is, numbers that are not prime. They have more than what? 2 factors. You get it? So in this case, 15 has given us 3. And 3 itself is a prime. Then we go to 5. Is 5 a prime? Yes, it is. So in this case now, we've gotten our final set of what? Branches, which are not going to continue again. So in writing our, what do you call it? The product of prime, then we are going to have 60 is equal to, with this, everything has been arranged nicely for you. You see? So that gives you your 2 times 2 times 3 times 5, which is the same as what we did on the left hand side. So 2 to the power 2 times 3 times 5. They are all the same. You see? So let's look at one last example and then we can end there. So this question here says we have to express 36 as product of prime factors. Express 36 as product of prime factors. Let's look at our solution. So we have 36, and I'm going to use both methods we have considered so far. So any factor of 36 at all you can think of. So, well, I can say 6 times 6 is 36. So I'm going to write my 6 and 6 over here. You see, and as you can tell, 6 is a composite number. Same applies to the 6 here. So they are both going to give us some branches. What times what gives us 6? We have 2 times what? 3. And the same applies here, 2 times 3. At this point now, you realize that 2 is a prime number, 3 is a prime number, and same applies to this set over here. Hence, we are going to say our 36 is equal to 2 times 2 times your 3 times 3. You see, and writing them as index notations or with index notations, we have 2 to the power 2 times 3 to the power 2. That is 36 being expressed as product of prime factors is going to be 2 squared times 3 squared. Now, if you want to strictly restrict ourselves toward the prime numbers, we have 36, and the first prime number, the smallest prime number that divides 36 is 2. So we have our 2, and 2 times what gives us 36. That is an 18. You see, then that tells us that 2 is what? Prime. We then focus on the composite number 18. So for 18, the smallest prime number that divides 18 is also 2. And 2 times what? Times a 9. Hence, we have our next prime number. Then we go to what? 9. So 9, 2 cannot divide 9. Hence, we end with the 2 and then move to the next prime number, which is 3. 3 times 3 gives us a 9. You see? So together, set, we have another 3 times 3 over here. And there is no other composite number we can continue with. Hence, our 36 written as product of prime factors is going to be what? 2 times 2 times 3 times 3. So 2 times 2 times 3 times 3. And our 36 is then what? 2 squared times 3 squared. Why do we want to learn this? Using this knowledge, we can be able to determine the highest common factor and the lowest common multiples of numbers very easily. Most importantly, for very huge numbers. Because if you have big numbers, you wouldn't want to go and list out all their multiples and now be looking for their common ones, or all their factors and now be looking for their common ones. Hence, we use the method of prime factorization, which we'll be looking at in our next lesson. But for this, I'll be leaving some exercises for you to try on your own. So here you have your try works. The first one says, draw a factor tree and find the prime factors of 96, 108, 75, and 60. These are beyond numbers where we learn maths the easy way. And I do hope this video or this lesson was helpful. If it is, and then this is your first time visiting this channel, you can always choose to subscribe. That is if you so do wish, so that anytime I release a new lesson video, you'll be able to access it as well. Stay safe and stay blessed. Bye for now.